Hello, and welcome back. In this section of the course, we're going to focus on some intermediate class design concepts. You may also think of some of these as best practices and other essential class design knowledge that you should keep in mind while creating your own classes. Since the topics that we're going to cover here are more concept-based, this section is going to be more of a lecture-style instruction rather than hands-on programming, which should make learning these topics much easier. We, of course, will be taking a look at some code samples of these concepts so that we understand how to implement them, but we won't be doing any actual coding in Eclipse for the next couple of videos. So in this lesson, we're going to talk about class cohesion and coupling. Now, when you're creating your own classes, they should be cohesive. This means that they should model a single entity and be very focused with a well-defined role. You don't want to try to represent two different objects or entities in one class. Nor would you want your class to be accomplishing many different types of tasks. The class should be very goal-specific, trying to solve one problem, not a jack of all trades. Instead, all of the methods and instance variables or properties of the class should be similar and related to one another, giving your class high cohesion. Now, by making your classes more cohesive in return, you gain a more readable class that can be easier to understand and begin working with. The class is easier to reuse since it's dealing with just one entity, and you don't have to worry about it running into any conflicts when working with other classes, and this makes them easier to maintain as well. So we want to make sure to aim for high cohesion in our class design. Now, how can you identify if your classes have low cohesion? First, start by looking at the name of the class. If it seems ambiguous or unclear, this may be a clue to having low class cohesion. Next, take a look at your methods. If you start noticing that you have several methods that are accomplishing a different task and dealing with a separate concept than what your class was originally intended to do, this is another hint that you might have low cohesion. Try moving those methods and that separate concept out into a new class. So let's now take a look at an example of a simple class with low cohesion. Here's some sample code showing a public transportation class, which models riding a bus for public transportation. We might have instance variables for the bus number, which is the actual bus that you're riding, the bus fee, which is how much it costs to ride the bus driver, and a few methods for getting the bus number, setting the bus route, and paying the bus fee. You'd likely have some other methods here, but I'm only including the bare minimum just to illustrate the concept. Now, this class has low cohesiveness. We're dealing with three different entities here. We have the bus itself, the bus driver, and the bus route, all of which are being represented by this one single class. So this one class is modeling three different types of objects. We could increase the cohesiveness of this class by moving each of these entities out into their own classes. That way each class is much more focused, and we could then have this public transportation class be the class that runs the program using the other three individual classes. So here's what it might look like if we moved the other entities into their own classes. We'll start with the bus class, which we can use to create individual buses, which would hold the bus number and the bus fee, and then we'll have various methods for working with the bus, such as paying the bus fee and getting the bus number. Then we have the bus driver class, which deals with only handling the drivers of the buses, and we can set and get the bus driver's name. Next, we have the bus route class. This class stores the starting location, point A, and the ending location, point B, which is the route that the bus will take. We also have a method to set the route that the bus should follow. And finally, we would have our public transportation class, which could now use the other three focused classes, which could create a bus driver, and bus route objects, and call their associated methods. So by moving the three separate entities into their own classes, we've now created much more cohesive classes that are focused on their own individual tasks of creating a bus driver, and a bus route, rather than all three of these entities being modeled in one single class. Now let's move on to coupling. Coupling is kind of like the measurement of how much one class depends on another class to do its job. In our last cohesion example, our public transportation class depends on the other three classes in order to complete its task of setting up public transportation. You may then decide to use the bus driver class inside of the bus class. At that point, your bus class would then depend on that bus driver class. Now, your programs can have tight coupling, in which a lot of your classes depend on other classes, or loose coupling, which is just the reverse. Now, you want to aim for loose coupling. By having tight coupling, this increases the chances of a problem cascading throughout your entire program, or having one change affect the other classes that depend on it. This also can make your programs brittle and complex because of all of the dependencies. Now, you're inevitably going to have classes that depend on other classes in your programs, but you just don't want it to get out of control. So here's a visual diagram showing loose coupling and what you should aim for on the left side. Each box represents a different class in your program. The dashed line and the arrows point to another class that it depends on. This style of visual representation is called UML, and it's helpful in showing the relationships between your classes in your programs. So this example on the left is loose coupling. Now on the right side is an example of what you should avoid creating. As you can see, many of the classes have lots of different dependencies on each class in the program, and it looks very complex. This is tight coupling. So what you should take away as the main point of this lesson is to strive for high cohesion and loose coupling. Next up, we're going to learn about variable scope, but that's it for this video, and I'll see you in the next lesson.